And now we're going to see how to write nuclear equations. And so the first general thing to understand, you're going to be given a nuclear equation, you're going to be given some words, and you got to decipher the words and figure out how to write that nuclear equation. Things that, words that you are introduced to that say that something decays or something is bombarded by or is bombarded with, those things are all going to be things that happen on the left. Those are what you're starting with. In general, reactions start on the left. We call those, well, in a chemical reaction we call them reactants and products. But in a nuclear reaction we don't really need those words most of the time. But in general, as we go, we start on the left, we have an arrow, and the arrow shows, it's a before and after picture. A reaction is a before and after picture. Before, you have the things to the left of the arrow, and after, they have turned into the things on the right of the arrow. I hope you got that sound. That was nice. Some keywords. Hey guys, stop making weird noises for now. You enjoy that? That's nice. So, as we go to the right, things that you know are going to be on the right, things that are produced, things that are made, things that are emitted. So just look for some of those keywords, and we're going to work some examples in just a second. But the key to doing a nuclear reaction is this. You have to remember that all of the mass numbers, the numbers on top, must equal before and after the reaction. So whatever your total is on the left before the arrow, that has to equal the total on the right. Same with atomic numbers, but we're going to do that separately. And you'll see what I mean in a second. So the total mass number before the arrow of all the things added together should be the same as the total after the arrow of all the things added together. And in fact, for some of the things, it won't tell you what is missing. There'll be like a puzzle. You'll find the missing piece, and you'll figure out what it is that you need to put into the equation to make it work out. So our first example is we're going to show the nuclear equation for the alpha decay of strontium-90. So that, again, there's the key, decay of. Sometimes it will say spontaneous decay of. Those are things that are just happening. You just have a nuclide sitting around hanging out, and it's like all of a sudden, oh my gosh, I'm decaying. And so it doesn't have to get bombarded. You're not putting anything on it. It's just happening. So we're going to write strontium-90. Strontium is Sr. It's its symbol, and it's, I'm going to write that bigger. Got to do this so it shows up. Strontium-90. And the 90, of course, remember, that was a bad idea. That's the mass number. So that's the number that goes up there. Down here, the bottom, you're going to get the atomic number, and the atomic number of strontium is it's 38, so we're going to have 38 protons down there. And so we're told that we're going to go through an alpha decay process, and what that means is it's just hitting there, hanging out, nothing hits it, it just says, hey, I'm going to change. So that arrow comes in, and it's going to go through an alpha decay. Well, we know what alpha decay is. Alpha decay makes a helium nucleus, and it's going to look like that. And so we know that basically 2 protons and 2 neutrons, or this helium nuclide, is going to come off of this strontium nuclide. But we know that there has to be something else. Well, what's left? Well, what's left is whatever didn't come up of that. And remember, the mass numbers on the right and left have to equal. So the mass number before the arrow is just 90. That's the only thing there. And afterwards it's 4. So what's missing? Well, there must be 86 more masses in there somewhere. And what about protons? Well, we started with 38. We've lost 2. That means there are 36 of these. So we've got the top and bottom numbers. Now all we need is a symbol, and we can figure out what this thing is. So 36 is the symbol, or is the proton number for krypton. So we're going to find krypton K. Oops, move over a little bit. Oh, ran out of space. Krypton. And so that would be the alpha production of strontium example. We'll make a new video for a beta particle production.